record on this computer. Okay, I am recording now. This is, let's see, what is today? Today is December 1st. After today, we will have one more class meeting, which I plan to use for a review. Okay. And let's see, we had to come up here. We are in a different room today, so I'm about fit to be tied being in the different room. And so we got moved here because they're doing something with the robotics in our other room. Well, we'll muddle through somehow. If you need to find your computer that you usually sit on, I have a map in the back that will take you to it. And let me bring up my Canvas. I should have done that already, but I've been swapping rooms. And as soon as my Canvas comes up, we are slow today with Canvas. Today I'm going to be doing the module that is called Database Design. Now this is a fairly, what's the word I'm looking for? A subjective module. It's not really a whole lot of programming in it. It is an important part of database. Let's see, where is it? Selected topics. We are going to go back up to module 12, which means that we have pretty well done them all at this point. And database design. We're going to identify tables and we're going to talk about coming from a specification. Now, a beginning database programmer isn't going to be designing a database, but I wanted to talk about some of the ideas that we use when we are beginning that process. So identify the tables, the columns, defining keys, relationships, and we have been doing that all semester, but we've been using them. There's a PowerPoint here that talks about database, what we call normalization. And when you have a normal database, normalized means this was first developed by a gentleman named Codd, C-O-D-D, and it talks about the relational model for database. So these PowerPoint slides are good. I might come back to them and use them. I'm going to step through this with what I have. Okay. A database is considered to be, I think there's about 5 or 6 normal forms of database. I'm only going to talk about 3 of them. Okay, first, second, and third. A database is considered to be in first normal form when it conforms to the idea that there can be no duplicate rows. Okay, and that the data are accessed by content only, and a field has exactly one value. Okay, now you remember I gave you that on about the first day of class, and I said this is first normal form. This is kind of what a database is. I'm not sure I'm going to let you call it a database table, at least, unless it conforms to that. There can be no duplicate rows. This speaks to the idea of the primary key. So all database tables have to have a primary key. That primary key may be one or more fields, but there has to be something that is unique and required about every field, every record in the database. That usually boils down to one single entity, one single item that I can call the primary key. Data are accessed by content only. It is quite possible to get the row ID. We haven't talked about that, but there is a row ID associated with every record, which is essentially a long integer number. It says, okay, it starts with 1 and 2 and 3, and they're numbered in order of the primary key. Problem with row ID is it can change, and they don't tell you when it's going to change. But if there are lots of programs that need access to the data that will use the row ID. If your code uses the row ID, it's not in first normal form. Only accessed by that value of that primary key. Last one is a field contains exactly one value. You'll see this one violated sometimes, and perhaps we have, because I ask you to find something about the area codes. If I talk about the area code, where the area code is a part of the phone number, you can get it. But I am violating that because now I am treating those data as if the area code were a separate data item. So if I'm going to do that regularly, I mean, yeah, I can do it once. If I'm going to do that regularly, I need to break out the data code, the area code as a separate field in the record. Okay. I don't like going in there and accessing it as a piece of it. I should take it all or nothing. Okay. First name, last name. If you're going to talk about the first name and the last name, they need to be in two separate fields. That's what we mean by has exactly one value. You will find in Access that you can have such a thing as a multi-valued field. Some of you have taken ITSW 1307, I believe it is. Yes? Donna is going, yes, yes. And you find that Access allows you to have a field that has the value of various possible values, and you just like check some buttons. Do we have this one or this one or this one? So I can check all of them or none of them or one of them. And now the value of that field is equal to phi. It's also equal to phi, but it's not equal to pho and phum. So a field can have multiple values in Access. And it's handy, but it's not part of database. Okay. So we say the key. First normal form gives us the key. Tables are related through the use of a foreign key that is almost always the primary key of another table. Almost always. We're going to look for some that maybe aren't. When we set this up, we are defining a one-to-many relationship. An example: a vendor may be associated with, I'm sorry, I'm not, I know I'm capturing the screen. Let me see if I can get this up on the overhead. Okay, what am I doing wrong here? I must have two monitors associated with this. See, how do I switch monitors? I'm afraid that I might stop my screen share. Gee, I'm not getting anything on my overhead. Let me. You have it there. Where? Right click where?
Oh, just drag that down. Go back to your.
Well, I'm capturing the screen.
Go down again. All right, right click on the desktop, then go to display settings.
Okay.
Instead,
I'm afraid if I click 2, I might lose it from
oh, yeah,
the.
will. Which is why. Duplicate. That way you got it up here, but the resolution's off because the changes. Can this go up to that?
I can turn off the lights, but
no, I don't think the projector can go up that high.
Okay, let's see what happens when we drop.
Monitor's okay.
All right.
So now you can just pop everything back up.
Okay. Believe I still have it. Okay, I'll go turn off. You want me to turn off the lights? I'm being told yes. Okay. I need to. That's the only downside of using that leash microphone. Is that okay?
Yeah.
I'm sorry, I can't get that any larger. Okay, for example, vendors and invoices is clearly a one-to-many relationship. One vendor has 0 or more. When we do a one-to-many relationship, the primary key of the one side is copied into the many side. It should keep the same name if you can, in my opinion. It doesn't have to. And it must have the same data type. Okay. Vendors thus is the one side, the invoices is the many side. So the foreign key comes over, and you had better believe that's something that you have to get down before you can get out of this class. Okay. There's another relationship known as the many-to-many relationship, and I'm going to put this out there for you. I have a table called owners. Create table owners, OID, and a name is all I needed to put in there, and a primary key. Just a primary key and a name is all I really need. Probably I have address and phone number and lots of other stuff in there. An owner has a 0 or more pets. The pet has a pet ID, it has a pet name, and it is associated with an owner, foreign key. The primary key is the pet ID. The foreign key is the OID references owner. This table will allow orphans. It's not constrained against not null. Okay. So I can have an owner, can have as many pets as the law allows. As far as the database is concerned, it doesn't care. I haven't lost anything by an owner not having a pet. I don't have any nulls anyplace. If the pet does not have an owner, I have a null value in the pet's OID. There's nothing wrong with that in a database. When I start thinking about indexes on this, the first thing I'm going to look at is that foreign key. How big will this table get? If it's a trivially small table, but if it's going to get very big, I'm going to index that OID. Not as unique, but I'll probably put an index on the foreign key. Probably, not always. If you were to say, put an index on the name, what you're telling me you're going to be searching a lot by the name of the owner. That's something that you're going to be doing every day. If you build an index on it, you're paying big bucks to speed up the search on that index. It'll speed up searching, slows you down other ways. Okay. Now let's move down to the tricks. How many tricks can a pet perform? Well, 0 or more. How many pets may perform a given trick? 0 or more. So I have a many-to-many relationship. Okay, this is one of my prime examples. And so basically my tricks, I have an ID, I have a name of the trick, fetch, roll over, play dead, and a constraint that sets the primary key. Now, the way I do this in database is I create something that is called a bridge table that I call a bridge table. People will call this by different names. Okay. The primary key of both of the related tables come over into this bridge table. So, am I making any sense here? The primary key of the bridge table, one option, it becomes both of them. It can't be any one of them, so it has to be both of them. That makes sense, because the pet ID can be duplicated. The trick ID can be duplicated. If I set both of them as the primary key, then I cannot again have pet 3 performing trick 27. So the way pet 3 is associated with trick 27 is I have a 327 pair in there. However, that 327 pair must be unique. Okay. Both sides of that foreign key are required. Anyone see another way to do this besides making both of these the primary key? What else could I do? Add one more field. Yes. And that's the primary key. Okay. I could do it with a timestamp. We run into this, something like a patient receives a prescription. Now it gets very patients and prescription is going to get very complicated, but let's take just the simplest form where I just have one database with a bridge table relating patients to prescriptions. So patient 3 is prescribed medication 22. I get a 322 in there. But patient 3 can be prescribed medication 22 again. Could be like a refill. So I would probably, in that case, I would probably put a timestamp on it. That would be the primary key. And then I would definitely index the other two fields, but they wouldn't be unique. So the constraint, the PID references pets and the TID references tricks. So when I have something like this, this causes me to have a many-to-many relationship. Let's see, I put this one in here. Okay. Here is the diagram. And by the way, you can do these database diagrams. If you right-click here and say a new diagram and add the tables, you get to see all the relationships. You can actually delete relationships here. It is not a good idea. I would suggest going back over to SQL. Notice the relationship pets to owners. In this particular one, we use the infinity sign, I guess it is, to show the many side and a key to show the one side. It's not always that way. Some database diagrams will put a crow's foot on the many side and an arrow on the one side. But it's always a one-to-many, because one-to-many is really all I have. And when you look at the bridge table, notice the way I can tell the bridge table. What is special about that? in this diagram? How can I identify it? I might very well have other fields in there. For example, I might have a level of competency on the trick. I might have a date at which dog 3 was certified as having performed trick 22. Right, I come out of it with too many sides coming out of it. So I have a 1 to many going in and a many to 1 coming out. And whenever I see that here and here, I have a bridge table type of a relationship setup. Let's go look at our database. If I can find it. Here we go. This is our the database for our accounts payable. I believe I have all of the tables in here. Notice that contract updates and invoice archive are just sitting over there. They are not related. So my question is, what exactly was the designer thinking when he or she wrote this stuff? I'm not too sure why they're not related. Contact updates, notice it has a vendor ID in it. I would expect that there would be some kind of a relationship, last name, first name. So this would be where we would update something. But I can only have one vendor ID, so I'm not real sure what they're doing there. I might change that table around. But let's look for a many-to-many relationship. Can we see anything that is acting as a bridge table? I see one. Invoice. Yes, invoices very definitely is a acting as a could act as a bridge table. And what does it relate? So vendors and terms have a many-to-many relation. So one term can be associated with many vendors. One vendor can be associated with many terms by simply the values that are in the bridge table. The bridge table being the one where many-to-many comes out of both of it. There's another one. Invoice line items is very definitely a bridge table. Invoice line items is probably intended to be a bridge table, whereas the other isn't. Interesting thing about invoice line items, I'm going to talk more about that one. It has some problems. I'm going to talk about some design problems it has. And we'll take a closer look at it. I like getting this is one place I will definitely use the graphical user interface. Every database, when you are sitting at the terminal of that database, every database will have a way to diagram that database. Access has them, Oracle has them. In Oracle, it's a separate tool that you have to load that will diagram the database. You just add your keys to it. Hello. Add your tables, and it will show you all of the relationships that are formed by the foreign key constraints. Questions? Very handy tool to use in analyzing your data. Mm-hmm. Sure. In general, you're going to look at your data. You know something about your data when you start the process of designing a database. You know approximately how big. You have a way of making a guess as to how many rows you're going to get in that database, and approximately how many people you're going to have using this database at any given time. Okay, that will make your decisions on what to make a table. For example, let's consider an employee database. Okay, first you set up your tables, and to set up a table, I need to define an entity. Well, what is an entity? An entity is something I'm keeping track of that has properties. Something in some databases, for example, if you work for a car dealership, you better believe that the cars will be an entity. Absolutely. That's what they're tracking. And I'm sure other things, parts and something like that. If I have an HR database, the only thing I really care about is how many cars, or I'm doing a census and I want to know how many cars does the family have. I don't care if they're red cars, blue cars, green cars. All I want to know is you have 2 cars or 1 car or 3 cars in your family. So that car is not an entity to a census database. Okay. So it's just a question of how many do you have? It's one example. So in general, you define an entity. I'm keeping track of something, an entity. I list my entities, what I'm tracking, and then the relationships between them. If I have an entity, a one-to-one entity, one person has 1 car. Okay. So this is an HR database, or this is a database, student database. And if you want to be a student here at Collin College, you may have 1 car, but only 1. We're only going to register 1 car. That's all you get. If you have 2, that's fine. Don't bring it to campus. Okay. Now, I'm not going to be very popular, but let's just put that as the rule on there. 1-to-1. Okay. If I have a 1-to-1 relationship, it's not an entity of itself. They can both go into 1 table. They can. But let's talk about that 1-to-1 relationship. Let me pull it up here. I think it's here. Okay. Here's my employees. And notice 1-to-1, you can only have 1 vehicle. So the vehicle is a part of the employee record. So when I create your record, I put your vehicle ID, vehicle information into your employee record. There is nothing intrinsically wrong with that. It is 1-to-1. That's fine. Let's talk about where are we? Where is our campus? Well, if it's in Plano, Texas, I guess we're in Frisco, aren't we? Anyway, here in Collin County, very likely we wouldn't put a restriction of 1-to-1, but let's say we did anyway. Let's move up to, urban Washington, D.C. In urban Washington, D.C., how many people have cars? If you live in downtown or central Washington, District of Columbia, do you probably have a car? Or Seattle? Where are you going to park your car? You live in downtown, you live in Capitol Hill or Queen Anne, there's no parking. Forget about parking on the street. The only thing you can do is go buy a parking place. And they, Matthew's saying they cost a lot. Yeah. Easily. So you're going to pay $500 a month just to park your car. Then you get to pay insurance on it and tolls and everything else. And then where do you want to drive? So they have good public transportation. You hope. They better. Washington, D.C. does. Okay, here's my point. Here's where I'm going with this. Very few of my employees will have that 1 car. So even though I am in a 1-to-1 situation, it would be a big win for me to break it out like this. This is employees 2. Notice that I just have the employee information there. Other means address, phone number, name. Name would be a good thing to know about my employees. It's lots of other stuff there. But notice that I've broken the vehicle out as a separate table. Okay, I have some information about the vehicle, but notice what I've got here. Notice that the EID, the employee ID, is the primary key of both tables. Pause there a minute. That's an important point. Tell me about the primary key. Unique. Therefore, if employee ID 123 has a car, employee ID 123 can only have one car. Suppose employee 123 doesn't have a car. Then employee 123 does not appear in this e-vehicles table. Therefore, I am not wasting any space. I don't have any nulls. And this is a very handy thing to do when I am expecting to have a one-to-one relationship, and frequently I will. Well, not real frequently, but occasionally these pop up. I have one-to-one that would tend to lend itself to putting them together in one table. So many of the database design textbooks say, if you have a one-to-one relationship, they go into one table. Not always. This one would be called a sparse relationship. I have a lot of nulls in there. When I expect that to happen, and I just need to know something about my data, or if I see it happening, I might break this out and have into two tables, so I don't have to store all of those nulls, because there's probably a lot of information I store about the vehicle. Your license plate, the vehicle make and model, I don't know, what else I'd store if I were a HR database, human resources, but I'm going to store some more information. The other thing that I can do is I can create a view joining these tables and make it appear as if they are one table, but I store them as two tables. Here's where I would certainly use a view. So when you open this view, you're going to see all these nulls, but they're not really there. It's just showing it to you in the view. So I don't have to store lots of null characters. And that is a big win. Questions? Okay. Let me go back to okay. Dogs and tricks are an example I gave. Next, I suggest that you look at the normalization video. I don't think I'm going to play it for you. To me, if it's available to you on Canvas, playing the thing in class is like reading you the textbook. I typically won't do it. But let me break it down. There are 6 steps it's going to talk about, and it's going to talk about each one of them. Identify the data elements, and I would call that identifying the entities. I would have said entities. I think I copied this out of the shot. Subdivide each element into its smallest useful components. Will I be looking for sorting by working with the area code of your phone number? Probably I will. Okay. I probably want your phone number broken out by area code, and probably I want the 3-digit prefix in a different field, because there's many times that I'm going to be working with it and I want to know everybody that's in the 940 area code with the 395 first 3 letters, first 3 digits of your phone number many times. Zip code. Many times I'm going to want to sort by zip code. Many zip codes have, what does it mean when a zip code has a dash and, so let's see, it's 5 digits with a dash and 4 more digits. What does that mean? What do the last 4 digits identify? Say again? I believe the first 5 digits tell you what country, what state, and down to what city. But I believe that the last 4 are where we have various post offices within a zip code. So then you pick up another one that identifies it further. You might want both of those in the smallest one. Identify the tables and assign the columns. Primary and foreign keys, big part. So does it have a many-to-many relationship, one-to-many? Step 5, it talks about in there structured or review whether this data structure is normalized. I'm going to talk a little bit more about that, and I'm going to wrap up pretty soon today. Step 6, identify the indexes. Okay, remember back to the last assignment, I believe it was, no, the last one was views, one but just before that where we talked about indexes. What is it that makes a good index? Something I care about. If I never search on it or only search on it once in a blue moon, don't index it. It's a waste of time. Hot field, I'm going to search on it. Other thing I want for an index, almost unique. Yeah, I always have problems with that. You're not supposed to say almost unique. It's either unique or it isn't. That's like saying, I don't know. So you either are or you aren't, but it's almost unique, works pretty well. I have very few duplicate rows. If I specify one row, I'm going to get 5 or 6 values at the most. That's a good one. Almost unique. I want data that don't change. Don't like to change. I want the data element to be as small as possible. So these are good things. There's no magic number that says, well, if it's over 24 characters, don't index it. But at some point, as it gets bigger and bigger, it becomes more costly to index. Okay. Do not index anything that is a primary key. Do not index anything that is as constrained as unique. Now, let's back up one step here. Let's go to where's our pets? Okay, let's look at PetTricks. Now, PetTricks has got an index built on it on PID, TID together. There is no index on just the PID in the PetTricks table. Am I frequently searching for one pet ID in that table? If so, it might be good to build an index on the pet ID and the trick ID separately. Okay. Because what is indexed is both of them together are in the index. Okay. If I frequently search by 2 values, for example, I'm frequently searching by first name, last name, then I might build my index instead of just last name. I might build the index on first name, comma, last name. I can do that. So if I say create index, I can create an index on 2 fields. So back to the, talks about the, what is this word right here? Heuristic. What does that mean? The other word that goes, a similar but different term is algorithm. If something is an algorithm, this says it is a series of steps, a finite number of steps that will always take you to a solution. Okay. A heuristic is a number of steps, a way of approaching a problem that will probably bring you to a solution. It will probably give it, there is no algorithm for writing a good essay. There is a heuristic. If you follow these rules, these steps of developing your paper, you will probably come up with an acceptable essay. That's the heuristic. So the process of identifying data elements is heuristic. We design a database to model an existing process that is currently either done by hand or some other system. Okay. So we're trying to improve it, and we know something about it. Very seldom do you ever design a database that is just completely up out of the blue. Anybody think of a time when we did that recently? Hello. So when have you seen it in, do you need to come in? Please. When have we seen that in recent history? Just, we're just gonna go on. Okay, can you think of a time when we brought a database up, a big system up, right off the ground? I guess we're gonna have more people in here than I thought, but I'm just gonna go on. They can learn something about database. There will be a test, so get out your pencil, paper, make sure you take notes, okay? Now, I was asking a question. When do we remember? About 5 years ago, we brought a major system online right straight out of the cold ground. And it had to come up, hit the ground running in December. But remember it? PPACA, Affordable Care Act, registration. Never had a chance to test it. It didn't exist, and then we created the database. Very seldom does that ever happen. Most of the time we come to our database, to our working model, by we're going to use an invoice, and this is what's on Canvas. We're going to use an invoice, and we're going to identify our data elements by what is on that invoice. What are they doing now? How can we maybe make that a little bit better? What are the relationships with these things? What are the relationships of the invoice to the vendor that is selling us this product or buying? In this case, I don't see a vendor. Anybody see a vendor ID? I guess this is the vendor up here. Salesperson, accounts receivable, and do we really need all of those items in our database? And as we go through it, and as you step through this data that are on here, we have the vendor name, the address, the phone number. We have lots of stuff on here that we're not going to put into one table. So we can identify here, I can certainly see one entity here, a vendor, an invoice, and there are clearly two separate ideas. So that's probably where I would start trying to tease this thing apart. Okay, as I identify the data elements, can I find values that are derived from other data on this sheet? I don't want to store that. For example, might need to know your age. So if we're going to have a party in here and we're going to serve beer, I need to know your age, because I can't serve you beer unless you're, what is it, 21 in Texas? 18, maybe 21. So I need to know your age, but do I need to store your age in the database? I can derive your age from your date of birth, so I probably got your date of birth. Okay. Anyway, if I can derive it, let's see, for example, the invoice total. Notice that they store the invoice total in our database. Do we really need the invoice total if I know each line item on the invoice? I don't need to store that. I can derive that. There's a few things about that. We're going to look at our database, and we're the one that we've been using all semester, and we're going to say, hey, can this thing be done any better? I think we're going to find out that it can by the time we get out of class here today. And I'm just about into this slide. This would probably be a good time to take a bathroom break. Okay, so I'm going to give you about a 5-minute break. I'm just going to let the tape run. Okay. Mhm.
So that video is probably off,
Okay.
off the screen or whatever still.
That's fine. I mean, the video is not important to me. Um, go back here. Okay, I have a little mnemonic for you. First normal form. First normal form, I want you to think the key. First normal form, the key. Second normal form. Second normal form says there is no part of the key that is not necessary. We're going to look at second normal a little bit more here, and I'm going to apply it to our database, our accounts payable database, and see if we are really and truly in second normal form. Sometimes you kind of have to say, am I there or not? If I have first name and last name in a field, have I violated first normal form when I say a field contains only one data element? I have first name, last name in a field. Probably a bad idea. My guess is that you're going to want first name, last name. But if you're never accessing a first name alone, not as a rule anyway, you haven't violated the first normal form. Okay. So first normal form, everything, a field has exactly one value, you're accessing it by those values, and you have a key, a primary key. Second normal form says the whole key has to be used. You should not have a key that, a primary key, even if it's unique, that contains something that you're not using or could get away from using. Now, let me show you an example of something. Let's go back and let's look at invoice line items, for example. What is the key of invoice line items? There, they have little key signs by them. Invoice ID and invoice sequence number. Let's go look at the data that are in invoice line items. I'm going to open tables, invoice line items, and I'm going to say edit the top 200 rows. Okay. Now let me see if I can roll this font up a little bit. See if it'll let me do that. No, it's not working. Notice the invoice ID. I guess you can read it. What does it do? It starts off at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And notice what happens when we get to 12. I have 12, 12, 12. So the invoice sequence is 1. So for invoice ID, invoice, I only have one invoice sequence, one of them. But when I get to invoice ID 12, I have 1, 2, 3, and 4. Do I have any others? I think there are some others in there. See if I can find one. Here's one. Invoice ID 78 has 2 associated with it. That's just about it. What's wrong with this picture? Can anyone suggest an improvement? Remember, I'm paying because I have that 2-piece key. I have both invoice ID and invoice sequence number are the primary key together. Do I really need that? Can I use either one of them as is? No, I'm going to have duplicates. What else might I do or should I have done? Well, it's going to be difficult to change because I have 3,422,000 rows in this table, pretend. That's going to be difficult to change. How would we redesign it if we had the luxury of starting over? What would you do with it? You could use a timestamp. Timestamps work fairly well. If you have data coming in very, very rapidly, sometimes it's not always, it doesn't always, sometimes I have to timestamp it out in the field and then send it into the database, and I might get different numbers. I could use a counter. Okay. In other words, the invoice sequence number doesn't have to be 1. It doesn't have to start at 1 for each invoice. Suppose the invoice sequence number were a unique identity, meaning the first one is 1, 2, 3, 4, 5, 6. And then when we get to 11, it'd be 11, and then 12 would be 12, and 12, 2 would be 13, 14, 15, 16. Is there anything special about the invoice number and the invoice sequence that has to be the same? I don't care whether it's, there's nothing in the 1 that has to tell me that that is the first one in the sequence. It doesn't have to be a 1. Suppose I had 352, 354, 355, 356. And the invoice ID would still be a 12, but the invoice ID doesn't have to be part of the primary key. So I say, show me all of the, I'd say, I would certainly index the invoice ID. Go out there and find all of invoice ID 12, show me all of the invoice sequence numbers that are associated with that invoice ID, and put them in order. Wouldn't I know the same thing? Okay. The key is first normal form 1. I'm in first normal form 2 when I'm using the whole key as part of the primary key, and it is required. Now, in this paradigm, the way this author is thinking, that whole key is required. Because if I have an invoice ID, I bring the invoice ID over as a foreign key, that's fine. And then if every time I have 2 or more invoice sequence numbers associated with it, I increment the invoice sequence number. For example, 12.1, 12.2, 12.3, 12.4. But the cost I'm paying here is I have a 2-factor primary key. I don't like that. If I absolutely have to, I can do it. It works. Yes, you can have a 2-field or a 3-field or a 4-field primary key. We would prefer not to. Any way I can get out of that, I will get out of it. I would get out of it in this case by making the invoice sequence number unique to the line in the table. And just let the invoice ID have duplicates in it. I don't have that many duplicates. That would make a very good candidate for an index, would be the invoice ID. You better believe I would, if I pull that out of the primary key, I would very definitely index vendor ID. He's going to be a foreign key anyway, so that's a good reason to index him. Plus, he's a very important field to that table. Questions? That's the first thing that jumps out at me that I would do for this table to speed it up, to make it more efficient. I left it that way, the way it was. Okay. Questions? The key, first normal form. Second normal form, the whole key. And finally, to third normal form. Quite often we leave it at second normal form. Third normal form says that there should be nothing else that is unique in that table other than the primary key. So there should be no other way to access the data by design. Now, if something just happens to be, if it just happens that a name, nobody has the same name, that's fine. I'm not talking about that. But there should be no other field that is unique and not null that is not the primary key. He needs to come out and become a field of his own. Many times you'll find trying to get into third normal form leads you to, for example, I have information about my students. And I'm sure that we keep on file your social security number. You have to have a social security number. That's probably the primary key. Then you are assigned a student ID number, but I'm going to guess that they don't actually store your student ID number. It's probably derived from your primary key, from your social security number. Because if I know your social security number, I can get your student ID number, but I can't get your social security number from your student ID number. At least I'm not allowed to. So if I'm trying to look up your record, something about it, and you give me your social, I can look it up. I can look up your student ID number. But if you give me your student ID number, I can't get your social security number, which is why we do it that way. What was I saying? Perhaps your driver's license number. And one little problem there is not everybody has a driver's license, so it wouldn't really work. But let's say you had to have a driver's license to be in school. Now I have the problem of I have two basically keys that I could use to access your record. I would have your driver's license number and your social security number. Either one could be a key to that table. So we say that table would not be in third normal form. Many times it is not really worth the trouble to go all the way to third normal form. But there can't be any other way. So we have a saying. It's like, you ever heard the truth, the whole truth, and nothing but the truth? That saying? Yeah. The key. First normal form, the key. Second normal, the whole key. Third. Nothing but the key, and then it has another one that goes with it. So help me, Cod. The boy's Cod was, what's his first name? I'll look up his first name. Dr. Cod was the person in the 60s who specified this relational database idea. And he's very famous. I believe he was Australian. I could be wrong on that. Okay, let me see if I've forgotten anything. Next. Talk about dividing it into its components. In other words, instead of putting the whole address in there, most of this stuff is pretty cognitive. I don't think I have to go over it in detail. You can read it as easily as I can tell you about it. Striking out some of them that we don't need, get some of them, some of the stuff we don't really need. Invoice total should not be included as a field in the invoice table because it is derived from the sum of the invoice line item amounts. I saw that pop up, and it just, every time I see invoice total as a monetary field, I cringe at the thought of putting that in the database as a field. If I can derive it, get rid of it as a field, derive it, present it as a view. So I would take all that. I would take my students I would have what would look like a table for you, and instead of showing your date of birth, it's going to show your age today, because your date of birth is somewhat confidential. Not really. But I don't like it being broadcast. I don't like to put my date of birth, my birthday, on Facebook, for example. I don't want somebody to be able to just go on, some total stranger go on Facebook and know my birthday. So I'm going to have a view set up that shows me your age today. From that, I could probably derive your birth date pretty close, particularly if I could watch it change. But that would be a view. So I'm never gonna, you'd think that I have your age in the database, but I don't. It's just a view you're looking at in a derived column. Let's see, I think I'm about done with these slides. Identify the relationships. This one has the crow's foot. You see these a lot. Okay. Crow's foot is the many side. So lots of them you see with a dot and a crow's foot, the many side. Pretty straightforward. One-to-many relationships. An employee can belong to many committees. A committee can have many employees associated. So when I see that many side going out of a table, I have a many-to-many relationship between these two tables. Whether that was the intent of the designer or not, that's what it is. Maybe they just meant to have a one-to-many relationship to employees. Maybe that has nothing to do with the one-to-many relationships to the committees. I might have other information in that bridge table. The bridge table might be an entity unto itself. Consider a prescription, right? A prescription is a relationship between a patient and a medication, a prescription. But a prescription has a lot more information on it than just to whom is it, what, and to whom. A lot of information on there. If I put information, if this were a prescription database and this were the patient, if I put information over here, it applies to the patient for all medications. So this would be like, this patient is allergic to penicillin. You can't take penicillin. Allergic. So my database, if I tried to prescribe this guy penicillin, the rules would kick in and say, oops, nope. If I put it over here, this would apply to a specific medication. For example, some antibiotics, you are not supposed to drink any milk with them, as I recall some. So they, or maybe do not drive and take this medication. That's one that works. Okay, so that applies to the medication. All patients who get this medication are not supposed to drive. If I put some information in the middle table, it applies to this relationship. For this patient and this medication, it says, take this medication 3 times a day with food, or something like that. So it has different meaning depending on where the information goes. So the bridge table, linking table as it's called here, may very well be an entity in and of itself. And the one and the many to one relationships, excuse me, may very well be accidental. Just because it has the many coming out on both sides, that might not have been their intent. One-to-one relationship, I talked about this. This is a good example. An employee has one picture, but not every employee wants to have their picture taken. Okay. If you do, I would do it in a like this. The employee ID is the primary key of both tables. Since it's a primary key, it is unique, one-to-one relationship. Sometimes that's a big saving. Mm-hmm. It can indicate lots of things. In our database, you mean? Oracle. In Oracle, that would mean orphans allowed, I believe, yes. Dash line would mean that the child key can be null. Okay. And then some other databases, it will find relationships. So it's called database mining. It will find a relationship and it will say, oh, by the way, this is a relationship, but it just isn't set up on a foreign key. I believe in Oracle, it means that the child can be null. I think I'm going to end there. This is a redundant slide. first normal, second normal, invoice data with the first normal with keys added. I'll let you go through this. I'll be in this all afternoon if I start trying to go through this. And I think I've already covered it pretty well. Third normal form. Second normal form, they're still claiming that it's in second normal form with the invoice ID and the invoice sequence. They're claiming that ours is in third normal form. I'll let you read that. The key, the whole key, and nothing but the key. So help me God. Are we normal? Find a field in the invoices table that depends on something other than the invoice ID. Consider the invoice total, okay? The invoice total does not conform to third normal form. Why? Because it depends on the sum of the invoice line items. So invoice line item amount, where you find the invoice ID and you add all those guys up, that's the invoice total. What would happen if they were two different numbers? Well, we have a problem. We have inconsistency in our database. Wrong data are okay. Inconsistent data I cannot tolerate. Right? If somebody keys in a invoice line item amount and they key it in wrong, my data are wrong. Okay, garbage in, garbage out. But if I have something, if my invoice IDs, invoice line items total up to $20, and my invoice amount, somebody makes a mistake there and puts in $25, now I have inconsistent data. It's two different things in two different places, and I never want that. So I'm going to get rid of the invoice total. Let's see what I'm doing for the quiz. Let's see what my assignment is. Word document. Okay. Quiz, chapter 10 exercises. You may do this as a Word document. This will be the first, last, and only piece of paper we turn in. Okay. If it is. If you do it as a Word document, you may attach it and submit it. You may use a drawing program. I would appreciate it if you would stick to something in the Microsoft Office suite. For example, do it in Excel. You can draw lines in Excel and Word. If you choose to, if you have to go in and draw your lines and your relationships, then I would expect you to scan it in if you have to attach it. So you may attach a scanned copy. Let's see, what is the portable? Well, PDF will work if you scan it to a PDF. What is the printer file? I'm freezing on that. There's a printer, not PRN, but
It's like Microsoft's default one.
Right. Yeah, it is kind of weird. Word is preferred. Okay, if you do it in a Word document, I can read it. If you want to do it in PDF, that'll also work. If you come in and you want to hand it in to me as paper, you may also do that. But that's the only time I'll accept paper. I prefer a Word document. I prefer a Word document. Design a database for a company. Explain your design decisions. So a lot of it, there is no set way that it has to be. Basically, I'm asking you to write something and tell me why you did that. So if you put an index on something, I want to know why you put that index on there. If it's not a foreign key, if it's not a primary key, well, you know, they're already indexed. Because I'm going to use that field a lot. And if you say so, then you are. Okay? That makes sense to me. Just don't, I put it there because it's a telephone number. When you put that database, when you put an index on a telephone number, I expect you to say, because I'm going to frequently be searching by the telephone number or something like that. Okay. Add them to the two tables, create additional tables and column, explain your decisions. Explanation of the decisions is the important part. I don't want just a drawing. Design a database that allows individuals in one or more groups. Again, explain your decisions. Okay. Now this one won't be, these aren't going to be real difficult. This one has what, 4 tables? Very similar to our accounts payable. In the 4 tables, you will design it, and you can, Excel works pretty well. And in Excel, I believe you have a drawing tool in Excel, don't you, where you can draw lines. And if it doesn't look, do something to show me the one side and the many side, okay? I don't know, I always put that little crow's foot on it. You could make it an arrow pointing to the one side, and someplace up above say, arrows point to the one side, and the tail points to the many side. If you say that, I'll be able to read it. Okay. Questions? Or you could go in and put little lines in there and make it a crow's foot on the many side. Okay. Questions? I'm going to make this due. Let's see, next class period, we're going to review and get caught up on any outstanding labs that we need to turn in. So next class period will be, I'm going to start from scratch and review. And then the following class period, we will, one other thing we're going to do next time for anybody that's here or wishes to have it, I'll have a conversation where I'll be available to talk about your particular grade. So I'll be available to do that. What do I have and all that jazz? What do you need to turn in? I think you can look at Canvas and tell that. So anything that's not turned in, we'll get it turned in. Questions? I'm pretty well caught up on grading. I have a few, I think for this class, unless anything that didn't come in yesterday is graded. If it came in yesterday, it's not graded yet. The final will be the Friday, 2 weeks from today. Okay. The last day to turn in assignments will be that day. So at close of business, when the last final is done, and I believe that is 6:30 on Friday, I'm going to close all turn in when the last final is over. So I'm going to expect the final to be a way for a person to raise their grade. Okay. Sometimes people come to me and they say, gee, I'm trying to get out of town. I have plane tickets booked for Haiphong or something, and they want to go. I am willing to entertain requests in that area. So it will be considered a way of raising your grade. I expect it to be. That is a difficult question for me to answer. And I have to take that one individually, privately. Wink, wink, nudge, nudge. Okay, others? So the final will be a same format? Yes. 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 Mm-hmm. I'm going to end the recording there. Yes, this is module, this is module 12, I believe. Let me look. Yeah, I'm going to stop the share. I guess I see my ugly face in here. And going to end the meeting. So everybody, goodbye.